Welcome back to Data Explained. In this episode, we're tackling replication, the quietly essential technique that lets a database survive a server crashing at 3 in the morning and lets it serve millions of reads without breaking a sweat. The idea is simple on the surface: keep copies, stay online. But how those copies stay in sync is where things get interesting. So let's start with the problem replication actually solves. Picture a single database server holding everything your app depends on. If that disk dies, if the machine reboots, if the data center loses power, your app goes with it. And even when things are healthy, every read hits that one box. So users on the other side of the world are stuck waiting. The natural question becomes, what if you kept several live copies ready to take over and share the load? That's replication. So here's the one-sentence definition to anchor everything that follows. Replication keeps live copies of your database on multiple servers, kept in sync so the system stays available and fast. 3 ideas are doing the work in that sentence. It's the same data, not a backup from last night. Those copies are continuously kept in sync, and together they let you survive a failure and spread out your reads. Before we go deeper, let's clear up a confusion that trips up a lot of people. Replication is not sharding. Replication copies the same data to many servers. Every node is a full copy, and that's what gives you availability and faster reads. Sharding does the opposite. It splits different data across servers so each one holds just a slice, and that's how you scale capacity and writes. Different problems, different tools, and in big systems, you'll see them working side by side. So let's look at the classic shape of replication. One primary, a few replicas. Your application sends every write to the primary. That's the single node responsible for accepting changes. The primary then streams those changes out to the replicas, which stay in sync and handle the read traffic. It's a simple split of duties. One machine owns the truth. The others keep copies and take the load off reads. So how do those copies actually stay in sync? The primary doesn't just apply your write and forget about it. It records every single change into a log, usually called the write-ahead log or bin log. Replicas connect to that log over the network, stream it continuously, and replay each change in the same order. The result is an identical copy of the data, running just moments behind the primary. Now, there's an important choice in how that streaming happens. With synchronous replication, the primary waits for a replica to acknowledge the change before telling your application the write succeeded. Safer, because nothing is ever lost on failover, but every write pays a network round trip in latency. Asynchronous flips that trade-off. The primary confirms immediately and ships the changes a moment later. Much faster, but if it crashes before those last writes reach a replica, they're gone. And that asynchronous speed comes with a quirk worth knowing about: replication lag. Replicas usually trail the primary by just milliseconds, but it's enough that if you write something and immediately read it back from a replica, it might not be there yet. This is the classic read your own writes bug. You've got 3 ways out. Route those fresh reads to the primary, wait until the replica catches up, or simply accept eventual consistency when slightly stale data is good enough. Now, lag is a small problem. A primary server crashing is a big one. And this is where replication really earns its keep. When the primary dies, the system promotes one of those replicas to take its place, and the app reconnects to the new primary. Done automatically, that handoff, called failover, turns what used to be hours of downtime into just seconds. So once you've got replication running, the next question is how you arrange those copies. The classic shape is primary-replica. One writer, many readers, and it covers most needs, but you can also go multi-primary, where several nodes accept writes. Powerful, though now you have to deal with conflicts. Read replicas exist purely to scale out reads, and cross-region setups push copies close to users around the world, so latency stays low no matter where they're connecting from. With those shapes in mind, it's worth stepping back to ask what replication actually buys you. 4 things, really. High availability. So a single server or even a whole data center can fail without taking you down. Read scaling by spreading queries across many copies. lower latency by serving users from a nearby replica, and safer operations since you can run backups or heavy analytics off a replica without bothering the primary. Now, where does replication actually sit in the bigger picture of scaling a database? Think of it as a ladder. First, you optimize your queries and add the right indexes, make the work itself cheap. Then you cache hot reads so repeat lookups never even touch the database. Replication is rung 3. Copy the data to scale reads and add safety. And only when none of that's enough do you reach for sharding, which means splitting the data itself. Replication gives you availability and RID scale before you take on that complexity. Before we go further, let's clear up 3 myths that trip people up constantly. First, replication is not a backup. If you run a bad delete, it cheerfully copies that mistake to every replica in milliseconds, so you still need real, separate backups. Second, replicas aren't always perfectly current. With async replication, there's a small lag, and reading right after a write can hand you stale data. And third, classic replication scales reads, not writes. Writes still funnel through one primary. Scaling writes is what sharding is for. With those myths out of the way, here's how to actually run replicas safely. Always encrypt the traffic between primary and replica with TLS. Never let it cross an open network in the clear. Keep proper backups alongside replication. Watch your lag continuously instead of waiting for users to complain. And most importantly, practice your failover before an outage forces you to. A failover you've never tested isn't a plan, it's a hope. So, who actually does this in the real world? Postgres and MySQL both ship with native replication. Streaming on one side, binlog based on the other. MongoDB gives you replica sets with automatic failover built in, and Redis pairs primary replica with Sentinel to handle promotion. If you want hands-off Postgres HA, Patroni is the go-to orchestrator, or skip the wiring entirely and let a managed service like RDS spin up replicas with a click. Let's pull the threads together. Replication is about keeping live copies of the same data. Writes go to the primary. Reads spread across the replicas. Async trades a little lag for speed. Sync trades speed for safety. When the primary dies, failover promotes a replica so the system stays up. And remember the boundary. This scales reads and availability. It's not a write scaler, and it's definitely not a backup. Now zoom out, and replication takes its place in the bigger toolkit. Indexes help you find data fast. Caching serves hot reads from memory. Replication copies the same data for availability and read scale. And sharding splits different data across machines for capacity and write scale. Replication keeps you alive and fast on reads. Sharding lets you grow beyond one box on writes. Together, they're how real systems both scale and survive. If this clicked for you, there's more where it came from. The Data Explained series digs into the rest of the toolkit: ACID and sharding, caching and queues, rate limiting and idempotency, deeper replication, and the wider system design picture. And if you want to actually run Postgres in production, that's its own craft. Replication, failover, backups, and hardening are what separate a hobby database from one you can trust. You'll find both over at Dargslan.com. Before we wrap, I'm curious about your experience. Have you ever written something, immediately read it back, and found it just wasn't there yet? Or maybe you've lived through a failover that quietly did its job while everyone held their breath. Drop a comment and tell me how replication has shown up in your work, the good stories and the painful ones. And that brings us to the full picture. Replication keeps you alive. Sharding helps you scale, and together they're the core toolkit for running data systems that don't fall over when things get real. Thanks for sticking with me through this one. If it clicked, hit subscribe so you catch the next entry in the Data Explained series, and swing by Dargslan.com for more. Catch you in the next one.